Welcome to part 2 or lecture 2 of Computer Science CS6000 research methods. So today we're going to look at a little bit more on reading and then doing a literature survey. So if we look at some of the elements of your PhD program here at UCCS, you have your written qualifiers, exams and courses, which you may or may not be done, but it doesn't really matter. That's learn a bunch of core computer science or security materials, not really related to doing the research part. Another one of your requirements to be done in the first year if you're funded, by the end of the second if you're not funded, is the oral qualifier, which is really a written survey paper plus an oral presentation. And it's very much related to what we'll be talking about in today's lecture. Then there's the comprehensive exam, which is your written thesis proposal and presentation. In it, a survey of the literature is really required. You're going to have that well done. And then your dissertation, which will still have a component of a literature survey. So last week we talked a little bit about reading and finding relevant papers. We're going to spend a lot more today, and we're going to talk a little bit more about how to take those ideas and organize them and present them in a meaningful way, although we're not going to actually get to the writing. It's just more about the organization of the ideas. So a little bit about how we read papers, read the abstract, look at the figures, but hopefully you didn't get too long where you went back to surfing. It can be a little bit tricky. People sometimes get discouraged going through that. But it's important that you keep plowing through it, because your chance of finding important articles that are relevant to your thesis, you get happier as you go through this. You find lots of relevant things, but you also want to make sure when you're doing your thesis-related survey that you've not found your thesis. And it's also an ongoing process. If you did that literature search today and you started on your research saying, yes, you have a great new direction, and 6 months from now that new paper comes out that's pretty much the same idea as your thesis, you are in trouble. So the process we talked about is not just something to do for your literature survey before you start, although you're going to do one before you start. You're going to have to keep doing that as we go through this. So when people think about their research, you also want to be careful. This is part of why the searching we did last week, I wanted you to also know how to find things other than just searching for keywords. Because if you put it in and don't find it, that doesn't mean it's not there. Finally, and something some of you may have struggled with, so if you're going to read this paper, especially when you're reading them in detail, you might have blanked out. You might not remember anything, and we'll talk a little bit more about taking notes as you're going along to make sure you're capturing that, because otherwise if you fall asleep and you don't retain the paper, it's not really going to do you much good. And by the way, PH.D comics is one of the things I loved. There's lots of fun stuff in there, so you'll see them in lots of our lectures. And finally, with respect to the process, if you got to the acknowledgments and it took you all day, you didn't do what you're supposed to in terms of reading. One of your assignment for this week, which we're not going to spend a lot of time on, though, you're supposed to be getting through a lot of papers. And if you do one per day, you're not going to get through enough papers. If you do one per day and you get through 7 in a week, if you're reading them in great detail, that might be okay. You're not going to read that many papers in great detail, but in the basic critical review, you should be looking at much, much less time. Otherwise, it's going to be a problem. And again, when you get done, you will have to retain what it's about. So if you think about the number of papers you found, you went through the process of the papers you found led to more papers. Many of those are going to be irrelevant. In fact, the whole point for you to decide which ones were not relevant, the ones you rejected last week, was because, in fact, most of them will be rejected. Most papers aren't related to what you're doing, but you have to go through them. And even though this is a comic, the total of papers starting at 240, getting down through, I would say, at least a basic scan or critical thing, 105, well, and 2 or 3 of those might be relevant. Those numbers are not horribly inconsistent. Hopefully you'll find a little bit more, because you'll be better at searching than just the random process. So as we're going to go through papers, we're going to actually talk about 2 different things, although we'll talk about both of them today. If we look at the types of papers, by far the majority of those are research papers, although most of those will have a literature review section or related work section, so what we're going to talk about for the review is still relevant. There's another important category of papers called survey papers, also called review papers. Survey papers are a great way for you to get intro to a field. I don't know if you've stumbled on any last week. Very often they are highly cited papers where you might be able to find a survey paper that really sort of puts a subfield into context. If you didn't find one, I suggest as part of your After you do your browse this week, because that's part of what you're supposed to do, if you want to go searching for some more papers, search for actually adding the word survey or review in the title of the paper, and you might find some other interesting ones. But this week, you're actually doing a browse, not a search. There are two other major kinds of papers that I'm not going to spend any time on. Clinical reports, which don't really have much in CS, or case reports, which are really a study of a particular event or case set of data, and not in the same level. And then the last, which I made even much smaller, what are called position papers. These don't have the scientific backing. These are really the kinds of papers that generally come out from senior members in the field that are sort of trying to push the field in some direction. And when you get to be at that point, you'll know what those are. So we're going to look today a lot at survey papers because that's something you all have to do, a survey of some kind, whether it's a survey paper or a survey section. And one of the things I want to start off is making it clear that a survey is not just a book report with a list of papers and a summary of each. A survey paper is a paper that summarizes and organizes recent research results in a novel way that integrates and adds understanding to the work in the field. A survey article assumes a general knowledge of the area. It emphasizes a classification of the existing literature, developing a perspective on the area, and evaluating trends. So it's important. It still has to add understanding to the work in the field. It is not simply a summary of each paper. When you go to do your oral exam, you'll have to have at least 10 papers. It's not just about saying here's a summary. It's really how to put those together, how to classify things together, provide a new way of looking at things, not just a list of papers and a summary of their abstracts and contents, because that doesn't add enough value for people. They could just read the abstracts if they wanted them. So in your survey, the real goal is to provide a reader with a view of existing work that is well organized and comprehensive. Okay? When I say comprehensive, I don't mean that all the details are included, but it's really important that you have to figure out which ones should and shouldn't be included, and that will actually depend in some sense on what the goal of the survey paper is. So if you're surveying something with respect to, say, performance, then understanding speed and memory might be important, and understanding the length of the code or the maintainability might not be the same issues. You want to make sure it covers all the relevant material completely with respect to what you're considering relevant. You've come up with a view of the existing work, and that defines what's relevant. And you have to have a sort of logical structure, the organization that puts that all together. It's also very important that you have some mixture of context, but also have what we would call a state-of-the-art view. When you get done, the most relevant and the current state-of-the-art needs to be summarized. The logical structure of organization might mean you do start 15 years ago because they laid the foundation for the sort of concept of organization that you're working through, but you have to be including state-of-the-art. It'd be very difficult to publish and probably wouldn't be very interesting to people if you did a survey of papers from the 1970s, unless you're in the field of history. So another thing, if you look at what a good survey paper would do, and now by good survey paper I mean something you're going to try and publish as a survey paper, I would say a good survey paper is going to summarize the research in somewhere between 25 and 80 papers on a particular topic. Could be more, rarely less, in terms of what you're going to summarize. The longest survey paper I did, I think actually had 150 or so references. And that's what's cited in the paper. We'll get back to how many I actually have to read to get there. You're going to include your commentary on the significance of the approach and the solutions presented in the paper. And I actually recommend while you're doing your reading, you begin to come up with those ideas. You might not keep all of the ideas you write as you think about and you do your creative read and your critical read, but you want to figure out what's significant and the solutions that are presented. You want to provide a critical assessment of the work that has been done. That's one of the reasons why when you're doing the critical review, it's so important, because that's an important part of what a good survey will do. You need to be able to put it both into context and critique it in terms of what works. And you want to have a discussion of the future research directions. And I shouldn't have to say this, but just to make it clear, if you're going to have to do a paper in this class, and I'll talk more about that when we have in our next class, we get a little closer. For now, you're just doing background reading. But if you're doing this, you're going to do a survey paper in this class, everything you write in the survey paper has to be in your own words. That's actually true if it's a research paper. Any ideas, paraphrasing other people's words must be correctly attributed in the body of the paper and in the references. And when we talk about that for the presentation, right, this is one of the things where it's not a great idea for in your notes for you to cut and paste text straight out of the paper, unless you also have a way of noticing that that is exactly a copy from the paper, because later on when you go to put it in a paper, you might be accidentally tempted to take stuff out of your notes. So if you use direct copies in your notes, find some way of marking them up so you know later on that you're going to have to rewrite them. So the sort of structure of an article, it's of a review article, it isn't just a concatenation of paper reviews. It typically has a title, an abstract, an introduction, and the body of work, conclusion, or future references. And the body of work here is what's going to be organized, where you really look at what's in the paper, and you're going to have some organizing principles. And we'll come back to some of those later in today's lecture. But the paper itself is supposed to be a contribution. It's supposed to have a novel view. You can't just really publish a paper that says, here's the standard view of the field. No one will care about that. It's unlikely to be published, and it doesn't add much unless you come up with something. Now, if you've analyzed papers in what was the same pattern as a review paper that was very popular 15 years ago, and you sort of update it with same taxonomy, but what's happened in the last 15 years, that might be there because you've analyzed a lot of new papers with respect to the same taxonomy. Normally, the field will have evolved to the point where you have to modify the taxonomy. You can't just use the old one. So now we're going to talk a little bit about your reading, and hopefully you've already done a good job of reading. I gave you lots of questions to ask when you're doing your critical reads, but I also wanted to add a few more things because I sort of missed some things that I really wanted to include. So when you're reading it, you're sort of being critical, and we talked a lot about last week about analyzing what's in the paper. Is it scientifically sound? The performance is good? Is it really important? Is it state of the art, etc. But a second step, which was implied by some of my questions, but might not have been obvious, is you're really analyzing what's not in the paper as well. What's missing? And especially when you're doing a survey paper, rather than just trying to read the paper for your own benefit. But when you're doing a survey paper, often what's missing is often a huge part of what helps you put it into categories, but also helps you compare and contrast two papers. If someone changes a metric and they don't measure something that other people have measured, you want to ask yourself why, understand, is that really an important direction, or is it something that was really not that critical because they already beat the algorithm that was discussed and beaten in the other paper, and so maybe it's not relevant. But analyzing what's not in the paper from almost all of the critical points of view is another thing that's important, and not all the same questions apply. So you have to figure out what's not in the paper and why becomes very important. As you're working on a survey paper, one of the things that people often try and do is make sure they're covering all the fundamental papers or all the fundamental research in the field. And you'll get into philosophical discussions with people about what is fundamental and what's not. And there's been endless debate about fundamental research, basic research, applied research, finalized research. The first, and some say definitive answer about is scientific research a value, is that it's a value as soon as it has been accepted by a scientific publication, okay, by a scientific committee. Okay. As you'll see, I don't think that's a definitive answer, but I want to just put it out there that some people think it is, so you're getting a full view. A second answer is the result has some scientific value if it's of interest to people and if it's original, novel, and hopefully if it has some genericity that is generalizable. It's not a bad answer. I can sort of live with that, but the third answer, and the one I consider definitive, is that a result has scientific value if it's cited by others, for example, in a reviewed published paper, in a patent, if it's actually used in a product, then it has value. It has scientific value only though when it's cited by others for its science, saying that it's good. This actually becomes important because sometimes citations can actually be negative, saying that the work is bad, in which case maybe it doesn't have lots of scientific value. Last week when we talked about citation counts, one of the things I didn't get into is whether or not you should be looking at it and counting how many of those are actually negative citations. There's a few papers out there that have lots of citations because the paper's wrong, or because the paper made some fundamental flaw and they are getting beaten up by other people. Not necessarily what you want in your career, to have your most significant paper be one that's beaten up. So in some sense, the most difficult and maybe the most interesting problems have often been raised by applications, medical applications, commercial applications. Investigating those properties that then go through a theoretical scientific development can turn into something really powerful. So my bias and the way I view things is research is only fundamental is that which helps solve multiple real-world problems. Until then, I just considered research or basic research. And in the field of research, you get a sort of hierarchy where some people think that basic research is more important than applied. And my answer to them is that if it's not actually being used by other people, then it's still basic and not as useful research. Fundamental research is something that actually helps solve multiple real-world problems. And so when you're doing your review, you can sort of use that to help put stuff together by not only clustering by how is the work done, but also looking at what are the applications. That can be a hierarchical way of separating kinds of data, and maybe even how close or how much did it impact those final application spaces. For a little break here, just sort of looking at it, some people think about different fields. When we talk about what's fundamental, this class is about research methods, and you should recognize that different fields have different research methods. So in the top comic, we're talking about social scientists use qualitative data, so interviews and life histories, and they consider that real data, whereas people doing literature research do something else. Be careful to understand that in those fields, those are the standards of care that one does research with. It makes them different, not necessarily better or worse, but also recognize that the standards of research methods in those fields don't really apply in your field. So, if you think about your research and feeling bad that maybe it's not useful, or the last comic is just really talking about that if it's years in the future before somebody will actually use it, then maybe once that happens, it's useful. Till then, it's research. It might still be publishable, but if you want to have more of an impact, you might want to find something that'll be more useful sooner. So now we start talking about how you're going to read a paper, and when you're doing a survey paper especially, but even when you're reading other papers, as you're doing your scans, you're trying to do your critical analysis, more so the critical analysis than the creative analysis, you want to look at the structure of a research paper. And we'll spend a lot more time, we'll talk about writing of the structure of a research paper, but a research paper tends to have this double funnel. So there's a funnel at the top. And the reason for the funnel at the top is that the introduction and the related work section tend to be very broad. The broader context you can sort of see, and then as they get to their actual, what their method can solve, things become narrower, where they get into describe their actual method and proposal. It's got a lot more restrictions on it. It doesn't talk about everything else that's related. You get through the experiments and discussions, and then at final conclusions, it starts broadening back up in future work how this might be applied to other things. And when you're doing your survey, the related work section and the discussion are the areas where you're going to find the most interesting elements for how to connect papers and how to compare papers across them. There's definitely some in the methods and proposed section and experiments that will be useful for your survey, but in terms of that, that's mostly describing the particularity of the results, not how to connect multiple papers across each other. So if I think about these sections of a paper, and overall the structure of a good research paper, not a structure of a good survey paper, this is a structure of a good research paper, there's what I would actually consider 2 + 1 key sections. You'll see why the +1 in a second. And I also want to point out that really when you're looking at a paper, a good idea, if you're, a very good idea, something that comes wrong very uncommonly, having 1 or 2, having 1 is good, having 2 is really exceptional. So inside a paper, you want to just keep focused. So when you're reading that paper, hopefully its key sections, its motivation and introduction section, is really going to get down to 1 problem and 2 to 3 contributions. Now, at the end, they can talk about a much broader motivation of other sets of problems, but in the end, they're going to focus on 1 paper, 1 problem. That problem might have multiple applications, and so notice I'm differentiating problem from applications. The same fundamental problem might occur in half a dozen applications, so they might actually show it on 3 or 4 applications. And that's why, in terms of contributions, there might be 1 or up to 3 contributions. Hopefully the paper shows it solves the problems. Contributions can talk about applications in multiple areas, and there could be multiple of those. So the first key section can be either the motivation section or the statement of the art, because people sometimes put those most relevant state-of-the-art things in the introduction and motivation section. Sometimes it's just in a separate section called the literature review, related work, or state-of-the-art. Okay? It's really important in a good paper, and when you're reading them, you're critiquing them, that the state of the art must not be flat or very general purpose. It's not like, well, here's, hand waving of what people in general do. The state of the art must be specific, cited references that are addressing a similar or very related problem and have a way of comparison that you can talk about. Right? If it can't be measured, you can't really compare against it, and it probably isn't state of the art. And it really has to be focused on your scientific and application targets. And when you in a good paper, they will already have done a critical and comparison of it. They will have contributions, the limitations, each of the papers they cited, and they're going to be analyzed with respect to the problem. And they're going to be compared, organized somehow. So when you're doing your own survey, this section is key to you understanding how to put this work in context, because hopefully the authors did a good job. If the authors did a bad job of their own comparison, then you might want to question the overall value of the rest of the paper, because good authors know that this is part of what they're going to do. So oddly enough, if you're trying to find out how to use their technique, if you're trying to understand what's the value of that work for you in the creative read, those contributions may or may not be that critical in terms of the comparison that they put in their related work section. But if you're first trying to decide, is the paper important, or if you're trying to do a literature survey, reading that section and understanding how they do it can be important. It's a little tricky because if you read 5 papers, there might be 5 different taxonomies, 5 different ways of comparing stuff. You're going to have to come up with a consistent or semi-consistent way as you're going to do your own paper, but it'll get you somewhere in the middle. So the state of the art establishes the benchmarks with respect to the work that's going to and how things are going to be compared, which is why it becomes difficult if multiple papers have different ones, but you'll find some way of putting those together in your survey. Ideally, all pertinent papers should be analyzed. Practically, that's often untrackable. It's often impractical to list all of them, just because you might be working in a field where the number of relevant pertinent papers might be 40 or 50, because depending on how you measure advances, there might be lots of related papers. But the process of making a bibliography is a key component of the scientific process. When you're doing your critical read, and we'll talk a little bit today about some tools, it's important that you should be thinking a little bit about what the taxonomy is. And when you're looking at papers, especially for your literature review, I recommend you make some comments about the paper that says, what was their taxonomy? What was their overall idea of organization? And some idea of what they compared with, because those might be useful things for you to do. So in your notes, you might want to include some of those. Those aren't questions about the paper in terms of your critical read. They're what you want to take out of the paper in your notes so that you can be able to do it. So as you look at papers, a common thing, we're talking about they're doing this sort of motivation of state of the art. I'm going to give you a way of looking at it that might help you organize that data, both when you're reading and when you're writing. So a good analysis that goes into the state of the art, I would actually call sort of a 2D, or what's sometimes called a T analysis, and you'll see why in a minute. And the objective of this process is to systematically classify the existing research in one of 2 dimensions. The first dimension is one of breadth, and this is really setting the scene or setting the context. It's in terms of describing the related things that are put together. And this is often where you'll get highly cited papers, because if you're setting the scene, you'll cite some of the other highly cited papers to sort of put this work in context. And the good thing of citing other highly cited papers is, if somebody has read that paper and you have a 1-sentence relation between your paper and that widely known paper, then they get to understand very quickly some of that, what you're doing, because they have a common frame of reference. The second type of references that go into this analysis in a literature section, the related work section, is what we would call the depth of the research. And this compares the particular topic of work that your research builds upon. And this is important because when you're reading that section, the introduction or the related work section, you're going to find both of these references. So when you're reading and you're taking notes about the papers, you might actually want to put them in one of 2 categories, the breadth or the depth. And when you're reading a paper that's only tangentially related to your work, so it's not part of the depth that you're going to end up citing, the things they cite for breadth might still be interesting and useful. Even some of the sentences and ideas of how they compare against that might be useful. And then the depth references become the very important ones if this paper is directly related to you. Now, I said we call this a T analysis, so we're going to actually look at 2 examples. Although the next slide says 3, actually I want to keep it short, so I'm just going to do 2. Knowledge management and information technology, both of which are sub-areas of computer science. So if I think of this as the reason it's called a T is I have this idea of a breadth of research which goes across the field, and the depth of research, which goes down in one field. And maybe you have two fields, so you get a pie, but in general, you sort of have the depth that's associated with this research. This might actually, although I drew it here as a T, it might be a little bit more of a funnel where you have the breadth, some slightly more related areas getting down to something very narrow, which is the most related paper to your work. So when you go to do the breadth of research and knowledge management, we might actually have a couple of papers where we talk about knowledge management, where we're talking about things like knowledge maps and knowledge sharing and elicitation, decision support systems. All of these are topics within the broader area or the broader domain of knowledge management. And you want to cite some of these for two reasons. They indicate your awareness of the broader field, and you know where your specific topic fits within the domain. And this is useful for people reading your paper, again, because it puts your work in context, and it also gives you a way for them to look at your topic and say, oh, well, I know other papers in Agile were relevant to me, so if your paper's in Agile, maybe this will be relevant to me as well. There's a secondary reason for this. When you're writing a survey paper or you're writing your own research paper, the people that you cite in your paper are the most likely group of people from which the editors will try and draw most of your reviewers. And so these people might be, if they can't find somebody in your depth, these people in the breadth might be the people that are relevant to the sort of your paper, and there might be the kinds of people you want to cite. Reading other related papers, you can almost always find some of these broader specific things that you think are interesting. And then, of course, we got to come back to the depth of the research. So the depth might be choosing one sub-area where you sort of have Web 2.0. And when you're looking at things, you might end up with a bunch of references. You get some set of references that are crossing the breadth, and then more and more references that are going deep in your area. Of course, different sub-areas, if I was in knowledge sharing or knowledge maps or elicitation rate, agile methods, any of these could end up being this. If you draw a T, which is actually pretty uncommon, although I've done a couple papers where we put graphs of how our references go in, you tend to draw the stuff you're actually doing sort of towards the middle, even if in this drawing I draw decision support, but if I were to do this, I'd put decision support in the middle of knowledge management so that everything seems to be more related to it. There's a sort of graphical presentational issue there. So to just do the same thing for information technology, I might be looking at image models, computer architecture, network databases, assistive technologies, agent development. And again, same thing. You're sort of showing your broader fields. And some of these might be closer than others. So if you're doing this and you're in networks, you might be talking a little bit about architecture, which has more relation, and a little less about assistive technologies or image synthesis, because those might be farther away. You don't have to cover everything. You're just going broader than your paper. You want this broad funnel that makes more people think this might be relevant to them, because if the ideas might apply to them, even though you only test it in your area, then it'll be narrower. And again, you'd go in the same topic. If I had something with databases, I'd have some broad stuff going on at the top of the field, and then I'd get into various research work by Codd or Boyce or Epstein in terms of actually dealing with databases. And again, each of the sub areas would have the same kinds of things. So when you're reading, I recommend you try and capture the broad area and its sub area in some sort of terms for you. It's really only 1 or 2 sentences, but you'd be surprised how after you've gone through 20 or 30 papers, this quickly helps you put papers in context. And with that, you might use those broader areas and sub areas as notes when you put things into your bibliographic database, which I'll talk about in a little bit. Okay, so that was the first key section when you're reading a scientific papers. Their own literature review helps you understand the paper in putting it in context on what's going on. The second section is what I would call the discussion. This tends to be at the end of the paper. Sometimes the discussion is in a section called conclusion because people have different styles of writing, but generally there's either a section called discussion or the discussion shows up in the end of the experimental section or in the conclusion section. But ideally an discussion section helps you when you're reading the paper because it allows you to deal with what's the initial objectives and motivations. It's sort of tying the experiment back to what was the original hypothesis, what was the original objective of the paper. It probably ties it back to the state of the art. And it puts those experiments in context. Might even discuss what experiments were not run. So in some sense, it's almost telling you, here's some of the things that are not in the paper, or they're in here, but they're not actually done. So you can sort of see that's an open area. Anytime there's not an experiment done is also potential open research direction for you to go. with respect to that, if you're writing one, you're going to be talking the implementation choices you've made and talk a little bit about how generalizable is this work. All of those things are part of what goes into when you're writing these sections, and therefore when you're reading them, you can sort of be looking for these same elements. Okay, the discussion is really not a conclusion. A good discussion doesn't draw a conclusion. It presents the facts and the relationships and lets the reader draw their own conclusion. You have a separate section to draw conclusions. In some CS papers, and more so in sub areas than others, the discussion is unfortunately not stated in some nice place. It's distributed over the paper, and it's sort of at the end of the algorithm section. There's a discussion of the algorithm. At the end of the experiment section, there's a discussion of the experiment. That's not necessarily a bad style if that's the style of the subfield of computer science you're looking at. If that's the way you're reading papers, you just sort of live with it because that's the style that people are doing. But there's one thing when you're doing your critical read, you shouldn't just believe the authors when they say here's the relationship, here's the relationship with respect to state of the art and everything else. You should also be making your own personal discussion in your head, your own limitations of what they're doing. So those are two key sections, and the third one, which I'm going to call the +1, it really isn't an obvious section. It's your contribution. Oh, that should say a third not obvious section. And it needs to be a sound. This is actually, in one sense, the most important part of the paper. But when you're reading lots of papers, this is the section that you very often leave to later, at least in terms of the most important parts of it, because you don't have to decide all of this until you understand whether or not this paper is relevant to you. You don't have to understand how they did it. You want to understand a little bit more about why in the beginning. It should allow people to reproduce the experiments. And if it's not, be clear and honest, why not? And my recommendation is if they can't reproduce the experiments, you have to be there are very special reasons. Sometimes you can't reproduce them because, for example, you're working under an IRB, and the IRB will not allow you to release the data because it would violate the privacy of the subjects, and then you have to be very careful what conclusions you do and how people might be able to reproduce it. So in such cases, it would be good to run your data on some other public data so that even if they can't draw the same conclusions about what happens in your experiment, they can compare another implementation on some standard data set and get a feel for where it is. As I said, generally in computer science, in some fields, this really is a section all by itself. It's generally not a section of computer science. It's often material that's at the end of the introduction where you might have a short summary of the contributions where it tells you what they are, and then you have to look for the contributions in the algorithm section, the experimental section, and most of the rest of the paper will have all those things. Okay. There are some sections that aren't really any of these key sections, but like one of those is the introduction to motivation, and this might be a key section if this is also where you have some of the literature review, but it may not be. The introduction is really inventing things that inventing something that no one is interested in makes no real sense. You don't want to do that. So if you can't motivate people in this section to read the rest of your paper will die and people won't read it. So when you're reading the paper, as you're going through that introduction motivation, you either decide this paper is relevant to you or not. And if it is relevant to you, then you read on and do other things. So it's sort of, oddly enough, a super important section when you're writing and a very unimportant section when you're reading, because you either quickly decide it's relevant to you or it's not. Now, when you're reading because you're doing a survey paper, the introduction might have more value because it might allow you to help understand how to categorize or put things in a hierarchy for your analysis. So there might be some other hints from the survey point of view in this section. Because in this section, they should also be talking about how it's going to be applied and put together. So to be interesting, your work when you're writing has to have something with a high scientific or social or economic value, and the problem is should have no good solution. You might have a solution, but you're going to be able to do better with that. That's when you have an interesting problem. And in the introduction, those should both be laid out. So when you're looking for understanding what does the user think is the value of the paper, whether it's scientific, economic, or social, you should be able to get that entirely out of the introduction. And that there is no good solution. They should have some generalized summary to sort of say what's lacking in the state of the art. They maybe have a separate section that goes into more detail. They may not. That depends on how the style is written. And the paper should list the criterion with respect to which the authors consider that their proposal is going to be evaluated. So at the end of the introduction motivation, you should have an idea how this paper is going to be done. That puts the paper in context. So for reading this section is important in as much as it decides, do I want to read this paper and what are the metrics I'm going to use to compare it? The next section is sort of the experiments. And when you're doing a survey, in the first reads, you can almost skip the experimental section. When you're doing the critical section, the experimental section becomes important. And at a certain level, experiments are often the sort of dark side of computer science research. In the sort of cultural, educational models of how we do this, computer scientists have often a unsatisfactory or limited education in statistics, experimental planning, and performance evaluation. This depends on the sub-area of computer science. In this course on research methods, we will only have 2 or 3 lectures on statistics and experimental planning. In many other fields, they have whole courses, multiple courses, on statistics and experimental planning. But we're mostly a synthetic field, so our things are a little bit different. We won't go into quite as much detail. The second is that real-life experiments are often intractable because comparing these 2 different computer science inventions itself becomes intractable. The software is not exactly the same. There's lots of variations in the systems. Very often the evaluation criterion are different, often by design. One person may have cared about speed, another person might have cared about memory. So you're comparing apples and oranges for many of times. But often that's just because the users chose to present it that way. When you're doing a literature survey, you can actually notice those differences and say, well, this technique can still be applied even though the authors chose not to evaluate it that way. And that can be an important part of what you're doing when you're doing your survey. In sub areas of computer science, there really aren't many benchmarks. More and more that's becoming a thing of the past. Almost all fields are developing some levels of benchmarks that people can work on. Sometimes authors will say they can't run on that benchmark because it's too big or too slow, they don't have access. So there's some things as you're reading you have to be careful to understand why they're not. And some research will address very small, specific issues that are very hard, but they won't do the integration, and the cost and difficulty of integration is both expensive, and sometimes it's what will make a difference in terms of performance, so you have to be very careful what those experiments do. When you're being critical, that's one of the things you'll be looking for. And many times research teams have neither the manpower, nor the competence, nor the infrastructure to develop products, and that limits their developments and demonstrations and prototypes that can't really be easily tested by end users. I can't tell you the number of times we've tried to get code from other people and been told they can't get it, or we get the code and we can't reproduce their results. We get their code, we can reproduce the results, but we can't actually get it to run on our data set. All of those are difficulties that make experimentation hard. Doesn't mean you shouldn't be doing it, but when you're doing your literature survey, you should become aware of those things, and often you want to take notes about what benchmarks they did, if they did them, which ones they didn't, or why they didn't, because when you're going to look for papers, that can be something you want to be able to find. You don't have to go back and reread papers to find critical elements. So if the paper is something that's really close to you, you think this might be something you want to think about as a potential comparison, take some notes while you're reading the paper about those kinds of things so you can sort of decide what it is you're going to want to do when you use it later. But really, in my view, experiments are mandatory to evaluate the pertinence of your work and the pertinence of anyone else's work. When I'm a reviewer, if I get a paper that has no experiments, then the paper better have lots of proofs, mathematical proofs, which are less common in most areas of computer science, because otherwise I can't evaluate the work. So we haven't talked about this, but when you're reading, experiments are something you might skip over when you're doing the first read, but when you come back and look for them, I often read the experimental section, oddly enough, not in order. I'll read the experimental section by jumping to the experiments and sort of seeing what do they compare with and how, and then I'll go back up and read the rest of the experiments so I can sort of evaluate that performance, whether it's efficient or whatever, with respect to the state of the art and in what context it's going to be. Because that helps me when I'm reading through the experimental design to think about not only what did they do, but what should they have done. So if you read the experimental final results and sort of the conclusions you want to draw, then you can see as you're reading through the experimental section, are those experiments in the right way to allow them to reach the conclusions they want. In my view, in my field, we're now getting to the point where our reviews actually have questions about how reproducible is the work. Experimental conditions really should be completely supplied, and maybe you only put that level of invitation in supplemental material, the tech report version. It's another reason why I like to see archive has been growing, because you can add an appendix of any length. Most ideal, which I try and push my students to do, is to actually release the code through GitHub or something else, but very often people are too embarrassed for that. At a minimum, the experimental conditions have to be relatively completely described, so maybe you don't give out your code, but if you had, for example, random subsets of data, and you don't say what those subsets of data are, no one can ever do a direct comparison of your work. So maybe what you do is you have a website where you say, even though they were random, you now list them in some index order so people can find them. You want to be careful to make sure people can reproduce your work. As you're reading through that, related to the experiments is this issue of sort of black boxes and assumptions. Very often computer systems applications are too complex, too large for anybody to be able to address the entire problem, so we may focus on a small issue or a specific part. In doing so, it's really important that you list the assumptions on the other parts in terms of the inputs and the outputs so that we have some clear description of what's going on. And you have to be careful. Some of those assumptions may be stated, but they're not really explicit. If I, for example, assume that I have an image that has been segmented, in my field, it's a question by which we assume that for every pixel you can tell me what the material is, and then I use that to do classification of the object. Well, that may be unrealistic as an assumption because that problem might be harder than the problem I'm trying to solve. And that's actually not an uncommon problem to assume. People have inputs that are more difficult than their own problem. And they may not say it explicitly. They've said explicitly, I use this as an input. But the assumptions that comes with may be more difficult to read. So as you're reading, ask if the assumptions are valid, realistic, and what they really imply. So as you're reading through a science paper that has some list of assumptions, analyze, are they realistic, implicit, or what they apply, and then always look for implicit assumptions, things that aren't stated. As I said, most problems I find with papers are not what the authors said in the paper, it's what they didn't say they did, or what they say they didn't do. The assumptions underlie all those things cause way more problems in a paper than generally what they chose to write, because they recognize that those were problems they didn't write too much about them. So when you're analyzing experiments, you really want to sort of look towards the borderline to figure out what's going on. Science definitely condemns treachery and falsification. If you modify the results of an experiment, you've gone way beyond the red line. You could lose your tenure. We've actually even had a case in the University of Colorado system where someone's PhD was revoked because they were found to have falsified data in an experiment. Just don't go there. It isn't worth it. Experimental measurements have to be presented in a paper, or at least they're supposed to be, in a way that is true. At least I've supposed it's true, and that's what you're going to do. So when you're presenting results, you don't want to try and mislead the audience. You might deal with stuff. There's always this weird question about sort of omitted or forgotten results. If you run something and you get a result that's really inconsistent with your results, and you just sort of forget about it, it's like, oh, that must have been experimental error. Be very careful what that is. You might want to go back and really analyze it. From a theoretical point of view, a negative result can be often as interesting as a positive result, although it's difficult to publish. Very often you have to put your negative results as part of a paper that eventually gets to a negative result. Although I have two of my first published papers were both negative results that proved you couldn't do something. They were harder to get published in part because of that. So a negative result is often considered a sort of depreciated fact. It's really just not that exciting. There's lots of things I can try and do and fail. It's only, in my view, negative results are only really interesting when you're going to the point where you can prove you can't do this. And sometimes if you can't do it, you might turn yourself around and say, well, could I prove that I don't? But that's back on the research question. But if a paper says we have a couple of results and we sort of admitted them because there was an experimental error, well, either they explain the experimental error or they can't. A joke I often like to use to put this in context is thinking about the hypothesis that all odd numbers are prime, which of course is silly, but you can say, well, let's see, 1 is prime, 3 is prime, 5 is prime, 7 is prime. I've run 4 experiments. Things look good. I'm done. Now maybe you want to run a few more experiments. Okay, 9's not prime. That's experimental error. 11's prime, 13's prime. I'm done. Out of that, right, you had 7 things, only 1 experimental error. You can say all odd numbers are prime. No, not true. You got to be very careful what conclusions you draw and how you get rid of experimental errors, and make sure they make sense when you're doing that. So the idea of a temptation to avoid or exclude negative measurements really isn't a good thing to do. This leads to a situation where bad results can happen in real life when you're dealing with it. Anytime you read lines like, and there's a whole bunch in this paragraph, anytime where you see some hint that the writer removes stuff, ask yourself why, and is it really meaningful? Did they somehow persuade themselves, delude themselves in my view, that the experiment wasn't pertinent? Now, that's not to say that there really isn't experimental error, but if there's experimental error, you should be able to go in, fix the error, reproduce the experiments, and figure out where it is. So in the sense, like, dropping experimental results isn't quite fraud. So you might say it's near the yellow line, but if you know the result is wrong, but you can't find any experimental error, then maybe it is past the red line of unacceptable behavior because you should have known that that result was wrong. And when you're reading them, there's also an important thing to analyze if the experiments were exhaustive. Now, exhaustive in computer science, we're not trying to try every possible parameter, every individual, but every meaningful set of parameters might be something that should be explored. If not, analyze to understand why they were missing and what it might do, and try and infer what could be the behavior of the prototype with respect to these experiments. Sometimes that can actually be a way for you to find a new interesting research direction, because if they only tried it for small numbers, the algorithm might not work at all for large numbers, or the other way around, there might be some special case for small numbers you could exploit. So as you're doing your reading, hopefully this will provide some more details about analyzing the experiments. I didn't want to overload you last week. This is something you do more when you get into your critical reads. The more that's closely related to your paper is after you've done your browse and you start finding stuff that's really tied to your research, this gets a little bit more detail about how to do some of those reads and some other questions to ask. So now I'm going to get a little bit into the literature survey, literature review, and it's really hard for me to overemphasize the implications of an incomplete literature review, because in the beginning you might be thinking you can't do this, and this is, again, a comic, but it's based somewhat on my own personal experiences. I've seen some of this as well, where people are thinking this problem can't be done, and then they find a paper where somebody's already done it. It's especially bad if you're not tracking it. One of the places where your advisor being tied into the field is good is for them to know what are people working on. In my own field, I know what lots of other labs are doing and know if they're working on the same problem. And they may not be working it the same way, but they might still scoop you, so you have to be very careful where that's going. But it would be even worse, and I've had a student who spent lots of time going down a path in an area that really wasn't my research area, but I was advising them. One of the reasons I don't do that so often anymore. And they were doing all this stuff, and then all of a sudden we found a paper that was pretty much everything they were saying they were going to do. The terminology was different, so their keyword searches didn't find it, but it was really the same idea, and they had to start over again almost completely and go down another research direction. So keep doing the literature research when you do before you begin your research, but also keep up to date on it, because you might have to find a way to try a new direction. It's also a little bit about what we call being scooped. You want to make sure you're not being scooped by knowing all the most relevant people doing related work, and you might even have conversations with those people so you know where they're going and how it's going on. So now I'm going to talk a little bit about the survey paper or the literature review section of your paper, because this is, something you're going to have to do. And so when you start to do this, as you're doing your more critical reads, and you're going to keep reading papers throughout the semester, this will help you sort of give a direction to where you're going for all those other papers. We're not talking about how to do your research yet. This is how to read those papers. Before I get into that part, though, I do want to comment. As you're reading all these papers in your notes, you should be thinking about what is the research process in those papers. And that might come up in the literature review. It might not. But I want to bring it up now, because the reason you're reading the papers isn't just to do a literature review. But part of the reason to read them is because of the literature review, so we're going to talk about that next. So we're going to divide this into sort of three parts. The literature survey, which is you doing the broad scans, a survey, lots and lots of papers. You're going to start that for this week's assignment. After you've done that, there's going to be sort of a literature comprehension where you really understand a sub-area of that literature, and then finally the literature review, which is more writing. So in sort of the first part is, again, collecting literature, finding all the relevant papers, which is a sort of iterative process. As part of that, you'll then eventually get to understanding the literature. And even though I haven't drawn it here, there might be a little feedback loop, because as you understand more, you might want to go back and do more of a survey to fill stuff out. And then finally, we're not going to talk today about how to write it, but eventually you're going to do reviewing the literature and actually doing the writing. But today we're just going to talk about how to sort of collect and understand the literature and put it into context. So the first part of the literature survey is the process of identifying, acquiring the research papers, whatever other materials you need, websites, theses. You're going to get a comprehensive overview. We talked last week about searching with keywords. I'm not going to go through that, but a focus survey technique is recommended to ensure you sort of hit the ground running on your research, make sure you're really going in a direction that doesn't already have somebody in front of you. Because if you're trying to follow somebody in the path, it's very hard for you to have the state of the art. You have to overtake them and do better than them. And if they're already working on it, you're probably already behind. It's less likely you're going to catch up. So using this technique are almost immediately to put you in a position to implement some experiments. If you can find a good open field where someone's not working and there's an unsolved problem. But to do that, you have to survey lots of space. And sometimes people get lucky and there's a problem sitting early in their survey. Other times you spend a lot of time going through it. Either way, those become part of your, some of them will become part of your literature survey, literature review of your papers. I actually consider it very important that you record the papers you found, whether or not you've decided they're relevant or irrelevant. So that's why I asked you last week to find 3 papers that you thought were rejected and why. I want you to start thinking about this is not relevant because. And as you collect that, you can keep track of that information. I don't really recommend after you get going. So once you're been doing a couple years, keeping track of the papers you don't read is not that important. But for right now, I think it is because it'll help you understand why you're making those biases. And we might even make you read 1 or 2 of the ones you didn't think were relevant, just sort of understand what's really in the papers because you might have misread that. But there's actually tools and software for these tasks. I'm going to cover these later on in this section of today's talk. If you know the exact domain of your research, it makes sense to initially focus your search on papers that are related almost exactly to your own research, rather than spending a great deal of time reading every relevant paper under the sun that seems remotely relevant. So if you already have talked with your advisor and you have a research direction, I'm going to make you do the browse, but you might do the browse as realizing that in terms of what you get out of that, you're not going to get as much. But you still might find something relevant through it. For those of you who don't yet have a thesis topic, you don't know exactly where you're going, the browse can actually be a very valuable way to both find the terminology, but also find a open space. As you're doing these papers, and if you don't have a research topic, you want to be thinking, when you get to those discussion sections at the end, the authors will often say, here's some of our future work. And I'm going to give you a hint. I would say in more than half the papers that you read where the authors say, this is our future work, they never work on it again. That is, what they really said is, here's future work somebody should do. Don't read it as here's future work I'm going to do. This is especially true and actually easy to detect if you find papers that were written as the students in their last year. If they graduated, they probably didn't keep working on that because they went to some other job and did something else. Their advisor may or may not, but it's very unlikely. Where if you're finding a paper from someone who's in their first or second year grad school, they might still be working on it. But either way, finding papers that have future work that sounds interesting to you, you can follow up with the authors and find out, are they working on it? And if they're not, then it's a great open playground because they've already said, here's some good work to do. You got a head start of what direction to look at. Okay, so as you're doing the literature survey related to finding your own work, right, one vital step is to identify what I would call the lexicon of the field. And this is related to the keywords, but it's a little bit more because the lexicon is really organizing those keywords in some grouping concept. What's related to what, how are they different, and that's the 2 things you're going to put together. And obviously when you're doing the literature survey, that's not the survey, that's going to be sort of your concept for putting the papers together. The other is having a lexicon that lets you find more papers. We already talked last week about getting more papers out of it. Okay. The second thing I strongly recommend is you have a notebook or an app. Most of you are computer oriented, so it's probably an app, where you keep track of all of that stuff. So this is obviously a very old notebook where people, I think this is, I won't guess who it is, I don't know. But keeping track of all the terms are really important. And if you have the right kind of app or the right kind of notebook, you're going to use that to record your research ideas you have about your research as well. Old style paper is fine if that's what you get you excited. I have Emacs, I just use text files. It's okay for me to record ideas because I can grep through them and look for stuff. Whatever you want to do to keep track of stuff. There's lots of tools. It's up to you to figure out what tools there are. But especially when you're first starting, keeping the records are useful, very useful. You might even use the same thing to record details of your meeting with your supervisor, even if, like many of my students, you audio record them. In fact, if you audio record them, you can get some programs that turn that into text. It's not perfect, but it's a lot easier than typing to put those kinds of things in your notes. You might also insert useful newspaper articles, pictures, or whatever that help you put your work in a broader context. You'd be surprised sometimes when those articles become useful for you to get ideas about how to justify the importance of your work. In that section where you're talking about why is this work important, you don't have to have scientific article citations for everything because you're trying to sort of motivate people. Understanding how newspapers motivate people, this problem is important, might help you learn how to write that part of it, even if it doesn't get a citation, or you can cite a newspaper. Okay. We talked last week a little bit about some good sources. One of your goals last week was based on your searches to figure out what was a good source. In terms of sort of reliability or credibility, Tier 1 journals, conference papers are sort of at the top. Tier 2 journals, where by Tier 1 and Tier 2, we're really sort of looking at their selectivity, their citation ranks, those kinds of things are the best journals. In the middle, I would actually put textbooks and some other books. And then Tier 3 conferences and journals down here. There's actually tiers of journals and conference papers that I actually consider so bad that literally if I find them on people's resumes who are trying to apply to be in my graduate program, it's like, no, these people don't know what they're doing. Just forget about them. Company websites and white papers may or may not be useful. In some areas, they're more useful than others. Blogs and wikis, anything that can be edited by anybody or where the person writing it is not an authority in the field, I don't really consider it very useful. They're often useful to get ideas because they're short and easy to find, but then you go find real sources after that. Talked a little bit about that last week. In computer science, there are really two main publishers who drive the majority of core computer science, and then there's a couple others I'll talk about afterwards. So the first is ACM. This is the Association for Computing Machinery. It's a large organization. In 2009, there were 90,000 members. It's probably a little bit less now as membership is waning in both ACM and IEEE. There's lots of local group chapters. There's a local chapter here at UCCS, and they have 35 special interest groups, and they do lots of the work in computer science through the ACM in terms of both journals and conferences. So SIGGRAPH is the special interest group on graphics, SIGPlan, special interest groups on programming languages and analysis, SIGC is the special interest group on computer science education, communications, and so on. They sponsor conferences and they do journals. Generally, anything that comes out of ACM that is sponsored by a SIG is generally pretty good. And so there's a long list of them. I'm not going to go through all this. You just Google ACM SIGs, you'll find lots of them. You can seriously see lots of sub-areas of computer science. I named a couple, but if you're looking for simulation, it's there, mobility, multimedia. They have lots of subgroups, and lots of those then run separate conferences. Another in the field is IEEE. Depending on what area of your of computer science, they may be much more significant than ACM. In other areas, ACM dominates IEEE. It depends on sort of the crossover. So things like IEEE transactions on knowledge and data engineering is an important one. The highest tier journal in IEEE is IEEE transactions on pattern analysis, machine intelligence, and IEEE transactions on, I think they changed their name, neural technology or something. It used to be neural nets. Those two are two of the most highly cited. But ACM or IEEE also has lots of things. IEEE transactions and then IEEE sponsored conferences. With IEEE, even more so than ACM, you have to be very careful about some things that say IEEE because IEEE is a publisher, ACM is a publisher, and you can get things where they actually have papers published in IEEE Explore by conferences that are not run by IEEE. And very often, those will have lower quality. IEEE sponsorship means that IEEE does a little bit more work and takes money, so it has to be run differently, to get them through IEEE. So IEEE conferences can be good. There are also some pretty weak IEEE conferences, and things that are simply published by IEEE but not sponsored by IEEE tend to be even a little bit weaker. There's a couple of other journals which I forgot to write slides for, but Springer has, in some areas of computer science, a pretty good reputation, and Elsevier also has a reasonable reputation in some areas of computer science. Both of those publishers, however, are strongly for-profit. IEEE and ACM are not for-profit organizations. So the others tend to have some oddly mixed motivations. And behind their paywalls, they will have papers, but they're publishers. So Springer just does books, and sometimes Springer books are really good, and sometimes they're So you have to do a little bit more per event analysis with things that are done by Springer and Elsevier. Both of them have really good publications. In many sub areas, the second or top journal might be a Springer or an Elsevier, but it's very now field dependent to figure out what that is. So last time we talked a lot about research things like Google Scholar and Archive, which I recommend you sign up for both of those to get, in fact, emails of those things that are relevant to you sent to you automatically or to search through them. I did miss some others. So DBLP is the database of publications for computer science. There's a bunch of computer science journals. There's also in there, you can also do a little bit of searching by authors. They have a list of things that are slightly different, so sometimes it's useful to look in there. The other reason they can be useful is DBLP will have the ability to download a well-formatted citation. Sometimes Google Scholar will give you a paper, but when you go to look at the citation, it's just not right. If you're not sure, go check in DBLP and you can help get those together. The stuff we talked about for searching, though, you have to be a little careful because searching, problem with using search information is really that there's a lot of things you may not find because of problems with trying to use text. So there's hypernyms and pseudonyms and anonyms and abbreviations across. All these make searching hard, which is why I also wanted you to go through the browse, which I talked about last week. And I also talked about the idea last week of basically using reference to referencing. So you take one paper's reference, use it to find other papers by either who is cited or who's cited by using Google Scholar. That's a very powerful way in using the related. So all of those, when I talk about doing a literature survey, you can't just use search word keywords. Even if you know that that's the area you're going to work in, you don't want to browse for other areas, you will simply not be successful. So use those other techniques of bouncing forward in time by looking forward back in time by finding who was cited by the paper that was relevant to you, and then finding who cited those relevant papers gives you another way of doing that. And if you go forward and backwards a couple times, you can easily get to hundreds of papers very quickly that may or may not be relevant. And also do the search within. If you get a paper that's got 1,000 citations, you don't go through them all. Do the search within that and use a couple of keywords, but be very generous. So, but be careful with your keywords. Go beyond them. As you're doing your literature survey, finding an up-to-date survey paper or thesis that is closely related to your research question can be really valuable, and at some levels really disheartening. But you should definitely be searching for survey papers. If you're doing a survey paper and you find a survey paper that came out last year on the same topic, you probably can't publish your survey paper. So it might be useful for the literature review section of your thesis or your research paper, but it's not going to be a good paper for you to write your own survey paper if that's what you're going to try and do in this class, because I'm not going to be happy if you do a survey that's just a rehash of somebody else's survey. Oddly enough, if there's a survey paper from last year and you think it's badly organized, that there's a much better way of organizing it, you might still be able to do a much better one, then it might get out. But it's still tougher if there's a recent paper. So try and find some slightly different topic, related but different, to make it good enough for you to do that. Reading somebody else's thesis, if you're going to read somebody else's thesis to get an understanding of what's going on, again, they'll have a literature review in that. The literature review in a PhD thesis or a master's thesis tends to be much longer than you'll find in a regular paper. So again, it's another good way of getting a lot more detail in the discussion. Also not necessarily a bad idea for how to write one of these sections if you can look through somebody's papers. Some considerations to be careful about, though. If you're finding a PhD in say Israel, it's going to have a very different process for what that literature review is going to look like than, say, one from the United States, which might be very different from one from India or China or whatever. So there'll be some local variations. Consider what they were trying to do with it. If there's a lot of overlap, you have to be careful with what you're doing. And again, you're not going to directly copy. But since you're aiming at trying to sort of highlight the gaps between what they did, what you did, reading theses can be very good because they're often very much state-of-the-art for the problem and give you a better idea for what goes into good quality research. Finally, be careful about the quality of the research. Is that at a place that's really good? Is the person somebody who's good? Have they missed any important papers or blocks of research? And if you start finding those kinds of problems, be a little more careful about anything else you're going to use from their research. Okay, so we talked about doing a literature survey. Last week, I briefly showed you how you could use the sort of My Library inside of Google That's great, but that didn't actually talk about how to build your bibliography. So I want to go a little bit deeper. I view my library in Google more as papers I should be reading. It's a reading list tool. If I want to build a bibliography, I'm going to use one of 2 or 3 things. I strongly recommend you move to LaTeX and use LaTeX, but sooner or later you might have to work with somebody who does Word, in which case you want somebody who's going to play well with Word. One of the nice things about this tool called Zotero is it can export references as a tool into Word formats, into EndNotes and in other formats for use directly in Word, just like text at the end of a Word file. And it can export bibliographies in LaTeX format, which is great. So this has become my de facto tool for lots of projects I work on. There's actually a web-based version of it where you can share references with multiple authors, which makes it nice. It's a pretty easy-to-use tool. It's free. Did I say it was free? You can download it and use it and keep track of your references. When you go to be surfing the web, one of the other reasons I've been using this tool a lot is it's very easy. If I go to some place and I've installed it in Chrome or Firefox, I can't answer for any other browsers, or maybe Safari, but I use it mostly in Chrome. If I get this little folder that shows up after I've done the search, and depending on which browser, there'll be some other graphical representation. But this basically says that if I click on this folder, I'm going to then get Zotero to pop up, and it's going to show me all the papers on this page. And if I click the box that's on this page, it's going to save that to my bibliography reference file. And depending on how I've configured it, it might save just the bibliographic reference. It might save a copy of the web page, or at least the first 10,000 or 1,000 words of the web page, so I have a snapshot. It can capture a snapshot of the PDF if you can have it, which makes it configurable and really nice because then after I've done this, I can actually have all the references sitting around. Obviously, you can only download the PDF if you can get to the PDF or whatever, but that makes it a very powerful tool. And then you get a lot of references in there. You can have different subsets of them. You can share them with other people and use them to generate bibliographies. As I said, I strongly recommend BibTeX. BibTeX is a way of both keeping track of and formatting references that are used within LaTeX. So there are various tools for things like export. Both Google and Microsoft, when you're looking for references, they can export them into a BibTeX format. The nice thing about BibTeX, and one of the other reasons it's useful, although it's also now true in Zotero because they keep the comments, you can add your own comments. So I didn't mention that when I'm in Zotero, but after I've downloaded a paper, I can click on the paper in my Zotero fields, and I can add my own notes to go along with it. So it becomes a way of organizing and keeping track of your notes. There's a couple others that I have friends that use, the sort of Pi Bibliographer and Biblioscape, EndNote. These are tools I don't use, so I can't really recommend them, but they are widely used in subfields, so you might want to explore them if you really want. A common question I get when people are working on this stuff is sort of, when have you found enough papers? At one level, the answer to me is, well, if you're still doing research, you're still looking for papers. But for a particular literature survey, there's going to be a point where you say, yeah, I found enough. There is no hard and fast rule. My own suggestion is you've got a good survey paper when you have between 50 and 150 good papers. But to get 50 and 150, between 50 and 150 good papers, you're probably reviewing between 250 and 500. You don't have to review them all. You're just going to sort of save them as a PDF and print it out in a pile if you're a paper person. You're going to sort of keep them in some format. Now, I don't actually do the browse that you're about to do to find all of those. The browse is also keeping up. But that's what I consider a really good survey paper. The biggest survey paper I have, I think, had 150 or 146 references or whatever. 50 is pretty common. I think the most recent survey paper we did on stealth malware was, I think, 80 or 90. You'd be surprised how quickly you get to that many references once you start linking papers to other papers. In this class, I'm going to expect you to have at least 40 or 50 for whatever paper you're writing. So there's sort of a style. If you're doing a research paper, there really is sort of an optimal number of references. If you have too few, people think you're making stuff up, you're not credible or whatever, unless you're a superstar in the field. If you have too many, people think you're not original, you're just building on the works of others. So you got to sort of put them together. The answer to how many is too few and how many is too many is very subfield dependent. Some areas of computer science 30 references in a paper would be huge. In other areas, that would be minimal. So it's up to you to figure out what's going on in your field. And to sort of give you a field, although this is real numbers of average numbers of citations in a paper for different sub areas of different fields. So in medicine, the average number, the average length of an article is between 5 and 6 pages. And hold on. Sorry about that. And then you can sort of look at them. But if you look at the average number of cited papers, it also goes up as the length of papers go up in different fields. The same is true in computer science. If you have longer papers, they tend to have more stuff in it.